Dear students, welcome to s.mathguru classes. Today we start the new topics of partial differential equation, Charpit's equation. Charpit's method. This is most important method and very easy also. We can solve some problem by using Charpit's method. Easily you can solve. The general method for solving partial differential equation with two independent variables. Let the general partial differential equation be f of x, y, z, p, q equal to 0. This is the general partial differential equation. Since z depends on x and y, we have dz equal to del z dx, del z del x dx plus del z del y dy. This is formula of total differential equation. So this is dz equal to, this means p dx, this means q dy. The main thing in Charpit's method is to find another relation between the variables x, y, z and pq. Let the equation be phi x, y, z, pq equal to 0. If we solving this equation and this equation, this solution is very lengthy. This will be long. So by solving this, we get a Charpit. I skip this steps. Just I want to write the Charpit's equation. Charpit's equation is dx by del f del p, dy by del f del q, dz by minus p del f del p minus q del f del q, dp by del f del x plus p del f del z, dq by del f del y plus q del f del z, d phi by 0. This is our Charpit's equation. Anyhow, you have to by heart this equation. We solve some problem by using this Charpit's equation. Consider one problem solved by using the Charpit's method. Px plus qy equal to pq. So solution. So this is our given equation, px plus qy pq. So consider f of x, y, z, pq equal to 0 is, this is px plus qy minus pq equal to 0. This means f. F means this equation. Now del f del x del x px plus qy minus pq, this equal to p into 1 plus 0 minus 0. This is p. Del f del y del y px plus qy minus pq, and this is 0, this is q into 1 minus 0, this will be q. Del f del p del p, this is px plus qy minus pq, and this x into 1 plus 0 minus q, this will be x minus q. Del f del q, this equal to del q, this is f means px plus qy minus pq. So this will be 0, y into 1 minus p. So this is y minus p, del f del q. Now we find del f del z. Del z, this is px plus qy minus pq. This will be 0, 0, 0. This is 0. This one we get 0. So we find all of this by Charpit's equations. Charpit's equations are, so this dx by minus del f del p, dy by minus del f del q, this dz by minus p del f del p minus q del f del q, dz by minus p del f del p minus q del f del q, dp by this is del f del x plus p del f del z, del f del x plus p del f del z, dq by del f del y q del f del z, d phi by 0. So this is our Charpit's equation, del f del p minus del f dx by del f del p, dy by del f del q, dz by minus p del f del p minus q del f del q, dp by del f del x plus p del f del z, dq by del f del y plus q del f del z, d phi by 0. Now putting the respective values, dx by del f del p, del f del p we get x minus q minus x minus q, dy by minus del f del q, del f del q means y minus p, so this is y minus p, dz by minus p del f del p, del f del p, this is x minus q, q del f del q, y minus p, dp by del f del x, del f del x means p plus p into 0, del f del z means 0, this is dq by del f del y, del f del y is q, q plus q into 0 and d phi by 0. So we get dx by minus x minus q, dy by minus y minus p, dz by minus p x minus q, q y minus p minus q y minus p, dp by p, dq by q, d phi by 0. So this is our Charpit's equation. After calculation we get this is the Charpit's equation. Now we consider one smallest portion. Now dp by p, dq by q, this one, and initially consider this is number 1, px plus qy minus pq, this is number 1. So we consider these two pairs, this one, this and this. So if we integrate both sides, dp by p, integration dq by q, this is log p, this is log q plus log a, constant a. So we get log p equal to log q plus log a. This implies log p equal to log AQ or QA. This is P equal to AQ equal. The value of P is AQ. Putting the value of P in equation number 1. Now 1 implies this is Px plus Qy. Px means AQ. This is AQ x plus Qy minus P. P means AQ into Q. This. So dividing both sides by Q, AX plus Y equal to AQ. One Q is cancelled. And Q equal to AX plus Y. We get this. This is our Q. Now we find P. P equal to AQ. And this is this one Q equal to AQ equal to this by A. And P equal to AQ, A into Q, AX plus Y by A cancel, we get AX plus Y. This is the P. We get this one. This AX plus A cancel AX plus Y. So we get the value of P this, Q is this one. Since dz equal to P dx plus Q dy. We know this formula, and putting the values, dz P means AX plus Y, dx, this is our P, and Q means AX plus Y by A dy. Just putting the values of P and Q. So we multiply both sides by A. This is A dz AX plus Y, A dx AX plus Y dy. So this can be written as A dx AX plus Y common, A dx plus dy. We integrate both sides, A dz AX plus Y, A dx plus dy. If we integrate, this is a constant AZ, and this derivative given here, this is AX plus Y whole square by 2. We get this one whole square by 2 plus another constant B. AZ equal to AX plus Y whole square. This is standard equation. This derivative given here, so this whole square by 2. This power is 1 plus 1, 1 plus 1. And constant is B. This is our required solution. So dear students, these are nothing, very simple, very easy, and surface methods, we can solve any kinds of problem by using surface methods. This is easy process. So I will discuss later on all the problems. Just you have to practice all of these. These are important for any engineering courses or BHC major also. And MHC also we have this type of problem. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, please subscribe my channel, click the bell icon. Thank you.